Okay, 6-6, trapezoids and kites. The objective here is to verify and use properties of trapezoids and kites. Okay, so here's our solve it. It says two isosceles triangles form the figure at the right. Okay, so that means that this is congruent to this and this is congruent to this. Okay, each white segment is a mid-segment of a triangle. What can you determine about the angles in the orange region, in the green region? All right, the angles in the orange region, one of the things we can say is that this angle is congruent to this angle, right? Because it's an isosceles triangle. Also, we can say that this angle is congruent to this angle. All right. Okay, key vocabulary. A trapezoid is a quadrilateral with exactly one pair of parallel sides, so only one pair. The parallel sides of a trapezoid are called bases, and the non-parallel sides are called the legs. The two angles that share a base of a trapezoid are called base angles. A trapezoid has two pairs of base angles. Now, an isosceles trapezoid is a trapezoid with legs that are congruent. So ABCD at the right is an isosceles trapezoid. The angles of an isosceles trapezoid have some unique properties. Here we go. Okay, here's the first theorem. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So this one, and this one, and this one, and this one. All right, so it says find angle measure in this trapezoid. So CDF is an isosceles trapezoid, and we know that C is 65. What are the rest? Well, we know that the measure of angle F is 65. And then if we think about all the sum of the interior angles of this, remember, is n minus 2 times 180. We've got four sides, so 4 minus 2 times 180. Therefore, we know it's 360. And we've already got 65 and 65, which is going to be 130. So if we subtract those, we're going to get 230, right? And then divide that by 2, and we get 115. So these angles here have to be 115. Same with this one, 115, right? Because it's an isosceles, so those angles are congruent. When you add all these angles up, you better get 360. All right, it's your turn, so go ahead and pause and do A. All right, hopefully you saw this is the same situation, so measure of angle S is 106. Again, the total angles is 360, and 106 and 106 is 212, so we have left 248 divided by 2 makes each of these 74. All right. In problem 1, if CDEF were not an isosceles trapezoid, would C and D still be supplementary? Explain. Okay, so if you remember, this is what example 1 looked like. It was that, and let me draw it correctly. Okay, the question is, would C and D still be supplementary? Well, yes, because if you think about, let's extend this. Okay, and there are parallel lines, and here's our transversal. They're on the same side interior angles. So they are same side interior angles. And we know that they equal 180. Okay, next, two more theorems. 620, if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. Okay. And let's see, what does it say? 5.1, you learned about mid-segments of triangles. Trapezoids also have mid-segments. The mid-segment of a trapezoid is a segment that joins the midpoints of its legs. Okay, so if a quadrilateral is a trapezoid, then the mid-segment is parallel to the bases. Cool. And the lengths of the mid-segment is half the sum of the lengths of the bases. Okay, so the length of this is half of this plus this. That's interesting. All right. QR is the mid-segment of trapezoid LMNP. What is X? All right, so the first thing we need to think about, what do we got here? Okay, so one of the things we know is that we know that QR is equal to half of LM plus PN. All right, so QR is x plus 2 equals 1/2 of LM, which is 4x minus 10, plus PN, which is 8. Okay, so now if we go through and we do our distributive property, 4x minus 10, so we've got x plus 2 equals 1/2 of 4x minus 2. Okay, now we're going to go ahead and that's simplifying. Let's go ahead and take our half through. So we got x plus 2 is equal to 2x minus 1, and subtract x, 2 is equal to x minus 1 plus 1 plus 1, and we end up with x equals 3. All right, now it's your turn. Go ahead and go for A. All right, hopefully you did the exact same thing as we did before. Mn is equal to half of the sums of the other two bases. So we got x is equal to 6, and the other question is, what is Mn? I just plugged it in and got 23. B says, how many segments can a triangle have, and how many mid-segments can a trapezoid have? And explain. Okay, for a triangle, a mid-segment connects the midpoints. So what if we had this midpoint and this midpoint, or we have this midpoint and this midpoint? So for a triangle, you've got 3. But for a trapezoid, you only have 1 because you only have 2 legs. So there's only 1. Okay, let's go here. A kite is a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent. Okay, so consecutive, one after the other, but the opposite sides aren't. If a quadrilateral is a kite, then its diagonals are perpendicular. That makes sense. Think about how you make a kite. All right, quadrilateral DEFG is a kite. What are the measures of angle 1, 2, and 3? Okay, so measure of angle 1 is easy because it's perpendicular, so it has to be 90. Okay, so if we know that's 90, and if we look at just this triangle right here, okay, so we've got 90 plus 52, which equals 142, and so all of the sums has to equal 180, so therefore the measure of angle 2 is going to have to be 38. Okay, so now we've got that. So we've got this is 38. Now one other thing you need to think about is if this is a kite, this is congruent to this. That means this angle is congruent to this angle. Okay, so if that angle is 38 and this angle is 38, now we've got 60, 72. So that last angle has to be, let's subtract that from 180. So you got 108, and we already have 52 of it, so subtract another 52, and we end up with, oops, what am I doing? Okay, so we end up with 656. So measure of angle 3 has to be 56. All right, it's your turn. Go ahead and pause, see if you can get it. All right, so we're doing the same thing. The first thing I did is I found out what the measure of this angle is right here, because that's going to be congruent to this one here. So I did 90 plus 36, so the leftover was 54, which makes this angle here 54. We know this is 90, so again we can do that. 90 plus 54 is going to be, okay, it's going to be 36. Or we could have said 54 plus 36 and see what's left. All right, key concepts. A kite has no pairs of parallel sides, okay? Quadrilaterals, only one pair of parallel sides. That would be a trapezoid. 2 pairs of parallel sides, you start going into parallelograms. You've got your rectangle, your rhombus, and your square. All right, so let's see how much you know. All right, so we've got angle 1, angle 2, and angle 78. So if we look at number 1, if this one here is 78, then we know that angle 1 is 78. So the measure of angle 1 is 78. Now, a measure of angle 2 is 90 right here, so we can figure out 3. So we've got 90 plus 78, which is going to give us 168. So the measure of angle 3 is going to have to be 12, because it's going to equal 180. Oops, 12, not 18. Okay, let's go to 2. It says, what are the measures of the numbered angles? So we have 86 and 48. So now we need to know what is the measure of 1 and 2. All right, so what you want to think about is that these are parallel lines, okay? And so these are transversals. So if they're transversals, these are same side interiors. So the measure of angle 1 is going to be 180 minus 86, which is going to give you 94. And then the measure of angle 2 is going to be 180 minus 48, which is going to give you 132. All right, that takes care of 1, takes care of 2. What is the length of the mid-segment of a trapezoid with bases of length 14 and 26? So for number 3, we'll use green. So for number 3, we've got a base of 14. We got another base of 26, and we want to know the measure of the mid-segment. So the mid-segment is going to be equal to half of 14 plus 26. So half of 30, 40 is going to be equal to 20. All right, last one next. Okay, vocabulary. Is a kite a parallelogram? No. Remember, the kite has no parallel sides? Okay, number 5, compare and contrast. How is a kite similar to a rhombus? How is it different? And explain. Well, the first thing we can say is that their diagonals are perpendicular. Diagonals are perpendicular. And the other thing that we can say is that consecutive sides are congruent. Consecutive sides are congruent. Now, how are they different? Well, one diagonal of a kite bisects the opposite angles, but the other diagonal does not. So one diagonal, this is different. One diagonal bisects the angle, but the other doesn't. All right. And also, all the sides of the rhombuses are congruent, not a kite. All rhombus sides are congruent, but not a kite. Okay, number 6. Since a parallelogram has 2 pairs of parallel sides, it certainly has 1 pair of parallel sides. Therefore, a parallelogram must also be a trapezoid. What is the error in this reasoning? Well, if you remember, the definition of a trapezoid is it only has 1 pair of parallel sides. There you go. All right, you're done.